Hello, everyone. Thank you for joining us today here on LinkedIn. I'm Joanna. I'm project manager here at IDZ, International Design Center in Berlin, and the UX Design Awards. A warm welcome to today's deep dive, where we present and talk with award-winning solutions in the field of UX. Today, we will be focusing on the product award winner DeltaApp, a full-service guided analytics platform, which was created by Bissantz and Company GmbH. And I am joined by Dr. Nicolas Bissantz, founder and CEO of Bissantz, and Dr. Fabian Rossi, head of product design and marketing. I will hand over to you both in a minute. I just wanted to take the opportunity to mention that our open call is currently underway, and there are 2 weeks left until the deadline, which is the 30th of November. Ta-da! So if you are thinking about entering the awards, now is the time. A little bit more also about our virtual event series, Deep Dives and Talent Tracks. This is where we invite award-winning designers and teams to present their work and share knowledge with our UX design community. It's a chance to learn from one another, get inspired, and start conversations. And with that in mind, for those of you joining us on LinkedIn, do post questions in the chat. I will do my best to bring them into the Q&A, which we will have after the presentation. So once again, a warm welcome to you all and to today's speakers. I hand over to you, Fabian and Nicolas.
Yeah, thanks very much for having us, Joanna, today. We feel very, very honored to speak here today in this deep dive. We have a lot to tell and a lot to show as well. So we should jump right in. I just quickly share my screen. So far, maybe just give me a quick heads up whether you can see the DeltaApp. Yeah, great. So this is the DeltaApp, as you said, a full service guided analytics platform, as we called it, visualizing company data in order to improve everyday decision making. What you see here is the result of more than 25 years of research, energy, and time. So it has been a very long way, hasn't it, Nick? Because the very first version of the software looked like this.
Yes, Fabian. It always feels a bit like confessing when you show that picture. It's true. That's how our first software version looked like. And yeah, to apologize, I can say it did not win an UX award, obviously, but it won another award for the integration of AI-based methods for the navigation through complex data. Yeah, but the picture is from the 90s. It is from our humble beginnings. And at that point, I have to confess, I had no clue that design should be different because perception is so different from what we think it is and from what we perceive, because perception is shielded completely from the possibility to perceive it yourself. That this is the case, that design needs a totally different approach, the perceptual design, as we call it today, and the DeltaApp is based on. That we learned from another gentleman, Professor Gerhard Roth, Germany's leading mind in neuroscience. He died this year much too early in full run, and it is not clear if his fellow scientists can follow in his path, as he was so far ahead before anybody else. We had the incredible luck, the good fortune to work closely with him for the last 11 years, one result being a 700 pages book about perceptual design that will be published soon, and its title will be Why Diagrams Fail and Numbers Must Be Reinvented. In our first encounter, Gerald told me, when dealing with perception, and especially in your field, when transforming numbers into knowledge, when getting complex messages across, I have very bad news for you. And one of them is that seeing is an illusion. I will try to explain that in a second. Second, thinking is expensive. The brain is lazy and picky, and for a good reason. It consumes more energy, oxygen, and glucose than the heart, despite the fact that the heart has to pump around all the blood. So evolution made the brain very selective in order to save that precious energy. And keep in mind, candy bars were invented much later than nature invented the brain. And candy bars were not at hand for our ancestors in the savannah. When it comes to processing numbers, things become even worse. We need the so-called working memory for that, to process numbers. This definitely is the weaker part of the brain, as some of us remember painfully from math lessons in school maybe. The working memory is very restricted in speed and scope. It can only work with 3 to 4 items at a time, works sequentially only, works slowly but tires quickly. Moreover, when it comes to numbers, seeing and thinking badly need exactly the same resources of this restricted memory part, the working memory, and strenuous seeing, which is given by complex visualization, can block thinking, as well as intense thinking can block seeing. Very important for our task. This is already very bad news for our business intelligence business, but there comes much more. So let's look at why seeing is so different from what we think it is. So this is, in a way, daily situation, and it depicts the world as we think it is. Flawless, movie-like, sharp, complete, in full color, rich in details, fluent. But this is not the case. It can biologically be not. Science says no. This is not what we see in fact. And this is due to physical limitations. To see sharply and in full color is only possible with the smallest part of the human eyeball, the so-called fovea. It has a diameter of 1.5 millimeters, and it can only cover a region that is about the size of a thumbnail. When you put out your arm at arm's length and close one eye, this what is covered then. This is what the fovea can cover. And this sampling is not fast. It's done 3 to 4 times per second, which is not much, as you can imagine. So this picture is showing what happens during 1 second. What is more is the extrafoveal vision, the so-called peripheral vision, is much more powerful. It's much faster than the foveal vision. Indeed, it covers a wide angle of nearly 180 degrees, but it delivers only blurred and colorless pictures. I'm simplifying a little bit here, but due to the scope of the talk, it's like that. As a result, when closing our eyes after 1 second, you should not ask us too many questions about what we have really seen. It might more or less be what we show here. And yeah, there was a speed limit. I can't remember that, but what was it? 80, 100? I don't know. I would have to look again. As another result, every distraction comes at a price. On the next slide, we see what happens when focusing on a detail. That makes the world around us disappear. And it would take another good 1 second to see that the car, remember it maybe from the last slide, that was on the left has now changed lanes and is before us. There, in that empty space where there is definitely no car in our mind, but there is one in reality. But we don't see it because we focus on inspecting where this truck has his home base. And I think this is a very important remark and helps us to be better drivers, avoiding focusing on details and trying to drive much more using our peripheral vision. To undermine that, let's do an experiment together. Let's imagine this is your view through the windshield of your car and to try to drive that band. And now please observe what your eyes are doing while you are driving. Try again in a little bit different setting. Again, drive that band, observe your eyes, what they are doing. Then here. And then in the last slide, again, try to drive and observe yourself. And now let's compare what happened. And if your observations are more or less the same as mine, in this top left pictures, the trees and the billboards seem so interesting. I had to look back and forth from the bend to both of them. I could not do anything else. Top right, same thing. The billboards still seem so interesting. My eyes are going back and forth between the band, the car, the billboards. Bottom left, now there's not so much left, but still it's the car far in front of me that I must inspect. And bottom right, now that most of it is gone, I can really focus on the band and maybe I start worrying if it is narrowing at the end. So isn't that good news? The guy, the seeing might not be complete as I've shown in those other pictures. It's error prone, it's an illusion, attention is scarce and so forth, but there seem to be universal principles how to guide the eye. But is that really news? In the next thing, in the next slide, we see a diagram, and the guy who made up this diagram might say, yes, in my diagram, colors guide the eye. I used elements which make something up like a gaze priming, and here it's the colors that lead the eye from left to right to decipher what I'm trying to say. Well, let us see with our new knowledge what this would look like from the foveal point of view, so to speak. Our vision would be obliged to scan that picture and put all those little samples together to make sense of that diagram. And on the next slide, we see what would be necessary as a gaze path, an eye track, to understand that slide. And now it comes into play what I earlier said, thinking and seeing draw from the same scarce resources. And so we can easily say this diagram is physically illegible. It cannot be processed by the mind because of those scarce resources of the working memory. So this is one of the many reasons for the title of our upcoming book, Why Diagrams Fail and Numbers Need to be Reinvented. And in the next slide, we have a short animation that uses one of the many elements we found to overcome that the situations where the limits of traditional communication make it so hard to get the message of numbers across. We call that idea typographic scaling. And actually we found out that making numbers graphical is a very feasible shortcut for our brain and works for many use cases. more about those elements which make our rules of perceptual designs now from Fabian.
Indeed, Nick. Yeah, that's so. The typographic scaling is also our very first principle we derived from all these years of research and also from all these insights we had. So, and if we just try making another experiment, if you want, please try finding the biggest number in this matrix. And it's not that easy. And to me, there is always a rest of insecurity whether I really found it or not. So it's rather hard for me. Maybe you already found it. But when we look at this, we see directly without even thinking about any numbers. So this is what we use in the DeltaApp, that effect that you don't have to search or remember or try your brain and lose expensive information and resources. You just jump at it at the 260 and you're there, and you find it just right when you need it. And that's the first principle. What you also see is the colors and the color intensities that we implemented here. This has a good reason, or rather it has three good reasons. The first thing, or the first aspect we have in here is, as we can see on the right, there are very different colors, and each color is more or less standing for itself. So the color, as Nick also showed in the diagram, they differentiate from each other, but they do not sort. And what we wanted to achieve with the DeltaApp is guiding the view to what's important with intensities. So we use two colors, in this case, red and blue, on the right side in the highest density. And when we lower the density, we can really guide the eye to a certain point. And we use that for indicating what's important, what's not, and what's worth a look or where it's urgent in our software. The second aspect of it is actually that business is always twofold. So we are situated in a business intelligence context, and there it is about profit and the factors that increase or decreases profit. So values can only be either positive or negative. There is nothing in between. No yellow, no maybe. That avoids making a decision. So the third aspect you can ask is, why did we choose red and blue? And that explains this diagram. That has to do with the wavelengths of the light, as you can see here, as red and green are quite close together and therefore harder to differentiate. We chose the furthest distance, which is, in our case, and physically, red and blue. So this one is about the color. The next one derives from also a business side of thinking, coming from numbers again. Let's say you have in your company, you have a table of sold units per day coming from different channels. Speaking of company departments, retail stores, or whatever. So sold units per day. You could deal with all these numbers and all these values in a big Excel table or anything, add it together and try making sense of it. But what you really want to know is the actual value is knowing the whole thing. So we want to start with a value that aggregates everything. Then you know, okay, my sold units per day were 4,191. And from there you go into the sections and see where is it coming from, which department was the best, who performed the best, and then you can really sort it out. And this principle we put in the DeltaApp, as you can see in the middle column with the 16.7 million. So the user always starts with the most important number and then navigates into his data level by level. We will have a closer look at this at the end and also in the live demo that Nick will show. And what the next principle is also based on the fact and derives from the one before, that understanding also and always needs a comparison, always. You can see that in the right column, the difference, and only if you can evaluate the difference, you can make solid business decisions. You can say, how does it affect me? Do I have to deal with it? How urgent is it? Do I have to deal with it now? So this principle is actually based on the fact that a single value, as you see here in this abstract visualization, that a single value does not say anything without comparison. Just a straight line, a red square, or a single number that does not tell much. But now, when we compare, we can actually see that there is a context about it, that it's and also this is why we call it the DeltaApp, because difference means delta, and the delta is always displayed right in front of you. So only if you can evaluate the difference, you gain insight. Is it bigger, smaller, better, or worse? Now I look at the red square and I see, oh, wow, that might be a signal. I need to look there. Or I need to look at the 124 because this is the biggest one. So it jumped into my eye only because we designed that context. Another principle that derives exactly from these thoughts is what we called the word size graphics, or what we also call it in short, sparklines. It's giving the whole story of the past, how the values change over time in a very compact, condensed form, and it lets you read it like it's just a word within a text. And in combination, even more, the word-sized graphics also, they end the alleged competition between, as Nick stated, between diagrams and tables. So we put this graphical pieces of dense data into a graphical element, and so we can combine the advantages of graphics and tables in one matter, or in one table in here. This one is another little experiment. As Nick also showed, please try remembering this number. Let's see whether you got it right. I read a few times, so I'm an advantage from this, but I bet it's a bit hard to remember, and that's why we go with this. So with this, it's much easier because you don't have to even remember. You just get it in the first try. It's 16.7 million. And in most cases, it's also as precise as you need it. Imagine when you talk to somebody and think about it, you don't say the whole number, it's 60,661,602. No, you would say, see, it's 16.7 million. So we've written the number as we say it. And with this, we can always guarantee that you feel the context of it and you have it right at hand. The last principle deals with the way we navigate through data. We saw this before also in the KPI first. We start on the lower left, on the upper left. And this principle is also rather simple. The more you tap, the deeper you get. You keep control over your data the whole time. So these navigation steps make even complex data manageable by controlling the speed and the amount of shown data. For example, you tap on the 16.7 million, then it drills down, it shows you the region, which region was the most successful one, had the most performance. In this case, it was south. Then I want to see in which product group was the most successful one. It's in this case a custom made, what sales representative was behind this. And so I can easily navigate step by step through my data, never losing the control. Despite that, if you would have that in a big Excel table, you would not know where to look at. So, and this is also the point, Nick, where we go live. So you guys can not only see the DeltaApp, but also get a feeling for it. So therefore, I just quit sharing my screen, and Nick, then you should be able to go on with it in the browser.
Okay, so you should see the DeltaApp web version.
Yep, indeed.
Yes, okay. So this is a use case. It could be the dashboards for a CFO, for a sales director, so revenues as a KPI. Fabian, you told us just a second before, KPI first is the most crucial thing to look at. Comparison is important, is key. So we look at revenues against previous year, previous period, and versus budget. And this gaze priming idea, I think, is quite obvious here. It's hard to miss the 2.0 million. If it's, yeah, this should be the default view normally. So it's very hard to miss that the 13.8 plus in revenues is the most important message. And the idea of this perceptual design is dynamic. So I just prepared here an example. Let's assume we were in a different period. So things would be totally different. Now our gaze priming works in another direction. It's, again, hard to miss. We have a good message, monthly sales, previous period, plus 13%, but we have also bad message nearly as strong. The red is nearly as strong in intensity as the blue, -5% versus budget. So let's go back to a more recent period. This was just for making clear how this gaze priming works. So over here, yes. And one thing that is very important, we don't want to clutter the user interface as we did, I confess, nearly 30 years ago with our first software version. We believe in haptic reasoning, not presenting too much numbers and finding gestures, finding interaction paradigms where the next thought provokes the next idea very intuitively, how I can find what is necessary to get this number on the screen. We call that haptic reasoning. So if I want to have an idea what this 13 plus 8% translate into euros or dollars, it's here where I change the two different figures. When I want to see how revenues translate into other KPIs, I can open up the whole, in that case, gross margin scheme. It's a very specific case, could be totally different numbers for other cases. And here again, we have this miraculous impact of color intensity Fabian just described. We even start to feel, okay, blue at the beginning, blue at the end, a stronger blue at the end. This is a quite uncommon situation. We have plus 13.8% more revenues, and this translates into much more over proportional gross margin 26 plus, and this must be due to under proportional variances in the costs we have to deduct here from revenues to arrive at the gross margin. And this is right so reflected in much lighter colors of red. And this is what is factual is here perfectly represented in colors and in their intensities. So you mentioned the function of stepwise drilling, and this would be done using absolute values. And again, it's benefiting from gestures we all know. Tapping is something that normally provokes some presentation of details. It's the same here, and we can change perspective very easily. Again, we see this magic feeling of how the simple scaling of numbers gives us a feeling of differences in distribution and frequency. So if we compare how those figures form graphical-like distributions, wonderful. Okay. Looking at my watch, I don't know, Joanna, could be time maybe to start the Q&A part.
Yeah, I think that sounds like a good idea. If you stop your screen share. Yes. There we all are in large format. Thanks so much for the presentation. That was really interesting to see what you've been working on for such a long period of time and everything that's behind it. So I think that what we learned about in the presentation was a lot your results. And I think it would be super interesting to hear more about the research process. So I'm sure there were different stages of how you came up with these principles and how you began, and then how you sort of tested on specific users, for example. So if you could talk me through the research, perhaps also the highlights. I'm imagining that you've done a lot, so you choose what you want to share there.
Yeah. So I think it was twofold. It was a very personal thing. I'm a researcher by heart. The company was founded on results we gathered during my PhD time at Phobos, the then leading Institute for Artificial Intelligence. And most of what we did during those research years is still in the product. So I'm a researcher by heart, and to get those research findings on the road, I had to create a company, you know. That was, but I'm still a researcher, so I kept on being curious, and I always strived to manage the company in both ways, commercially successful, but also as a think tank that is financing ground laying research work. So this was one aspect. The other aspect is from a commercial point of view. There were many things I felt intuitively could not be right. One example being what was for a very long time very fashionable in our scene, that is traffic light coloring for results. Red, green, yellow, and I'm not talking here about green versus blue. This is another topic. But to create a yellow maybe, and to find thresholds, and the danger that responsibility is reversed because a CFO won't have the time to define all the thresholds along a deep hierarchy of data of organization. So this will surely be delegated downwards. So it's other people who color results than people who have to decide what to do with those results. And this actually ended in information catastrophes. German newspapers could realistically link some of the problems that the Landesbanken had during the financial crisis, and even those ridiculous things that happened with our airport in Berlin could be linked to this traffic light function management system. So, and we felt this is wrong. But our clientele at that time, they nevertheless asked for it. So if we could not provide it, they deducted, yes, because you were too lazy to program that, it's not technically possible. So it was critique. So we were forced to be commercially successful, to program a lot of things we afterwards advised our clients against using it. So that made me crazy. So at one point I decided, no, we need scientific research. We need scientific proof, and I need, in German you say Totschlagargumente. We need knockout arguments. And if you say a German professor has told us that, that's a very strong argument. And that was the time when I thought about who knows human nature best, who understands the limitations of perception, of understanding, and who could back me up. And at that time, as I said, Gerhard Roth was very well known, the leading scientist, and I asked him for help. I exactly explained this situation to him. And so we did a lot of workshops. We presented examples. I explained what clients would have as a critique, and we discussed from what angles of view we could attack those arguments and how to prove that we were right. And this also, that was one part. And the other part was, as I said, I'm a researcher myself. And we experimented as far as perception research is concerned with lab research using eye tracking technology. And this was another turning point in my career, because we had those technology that was around at that time, and I sat before them and I looked at our own design, and this was filmed and all that. And when examining what we had registered, but what we had filmed, I clearly could feel, yes, my eyes were wandering about those screens, and this was registered by eye tracking. But what I thought about that at the same moment was totally different things. I was thinking about my what I was wearing, because we had this film crew around me, but my eyes nevertheless were inspecting what I had before me. This is how the eye works. So I understood that eye tracking is registering eye movements, but it's not registering what you think about it, or if you think about it at all. So this was the point when we decided we need a completely different environment. We need something where we know what good seeing means, where good seeing is related to performance that can be objectively measured, and a surrounding where we can use eye tracking technology. And at that time, a new thing came up. It's glasses you can wear. It's eye tracking mobile. And we found Hans-Joachim Stuck. I was a bit in race car driving myself, so I knew some famous racetracks and how how the sequence of gaze should be there to have a fast lap time. So I was competent in a different field. And I asked Stucki, let's take 2 laps or more around the Nordschleife and register your eye movements. And actually, I don't know what will come up out of that, but it will make us less stupid, that's for sure. And it did. And we had 20,000 pictures and the filming and all that of his eye movements around the most famous, most dangerous racetrack in the world. And this brought a lot of scientific proof about how what techniques people use who are totally aware of the limitations of seeing. It's their daily business, you know. Stucki, maybe he's not reflecting that, but he's unconsciously aware of that his gaze around this track is eminently important for lap time. So then we found Dennis Eitekin, very famous referee in Germany, and he's a very intellectual guy. He's an IT businessman also, and he first intuitively, then systematically became aware of the limitations, and he developed very specific strategies how to overcome the difficulties in right decision making in soccer, with using probabilities, with pattern recognition, and what else. Then I visited the sport university in Cologne, where there is a specific department with very competent persons that train our best sportsmen and sportswomen in their eye capabilities, in their gazing capabilities, how fast they can use their saccades, how precise one glance from one point to another can be, and so on, and how to improve peripheral vision, and so on. So there were several sources we could derive from. Yeah, I think that's the most important aspects of which should answer your question.
Yeah, I think it definitely answers for some of it. I was also thinking about more specifically how you then applied this science and knowledge to your specific user group and the people who would be using DeltaApp. For example, did you do usability testing on a specific target group to make it smaller? And then I was also wondering about, it just struck me that it's a large focus on vision, and if there was also a thought to take into consideration also the other senses, like I guess it would be hearing and touch into your findings.
Yeah, absolutely. So this all took place along our normal business. So over the years, we were doing several thousands data analysis, financial controlling projects. So for every step in the development of our software, we had projects, we had customers, we had the possibility to look over their shoulders. And by that, refining, finding some things we did not get right at first. So this was a very hard test because, if we would fail, they wouldn't buy it. So this was one very important thing. Real customers, real money involved, and they feel it's an advantage or not. And another point is that this all took place when presenting one software version with customers very used to an old one. This adds complexity because if you're accustomed to something that might be not ideal, but you're accustomed, this is an advantage. So the new idea must even better for a customer you already have than for a new customer. So this was a very hard challenge. But all in all, the idea of working together with Gerhard Roth, that was for more than 11 years, was really extracting the universal laws. And a universal laws must not be tested against 200 different characters because we all have the same brain. We may have different abilities, but there are, when it comes to perception, the variation is small. A tennis player has incredible fast saccades, but this is not, we are not selling software to tennis players. So our clientele is quite common, and their vision abilities are quite comparable. So if Gerhard Roth cites a colleague that blue and green are wider, that the distance in the receptors are wider than for green and red, that's a fact. So, and this fact leads to the insight that the differentiation, if you are a bit colorblind or not, that the differentiation between blue and red is easier to understand than between green and red. So this is universal. You can lay something on that. And so it differs a bit, some things are universal, other have to be adapted. It was a very mixed process of testing and retesting and finding the right way.
Also
and
in
not
another,
at the end of all that.
Yeah, also in another part, I think what you're going for, Joanna, is that we had for sure not problems, but challenges with applying the rules you just saw and all the principles to the several devices, and also maybe not focusing on the visual input, but also maybe thinking of what else is it. So it's the visual input. It impacts or reflects on a thinking issue. So like when you see that, you think, okay, I go there. But there's also other senses, and maybe I can quickly share my screen again to show actually the whole collection of the DeltaApp, which is this. You should now, I hope, see it. You see there 3 formats. In the middle is the desktop version. On the left is also the desktop version for iPad format. And the responsive design on the right, you see the mobile application. And what you mentioned, Joanna, what we kind of a bit struggled with is how to adapt these principles not only regarding the human recognition and perception, but also outputting them in different formats or media. Like the interaction on a smartphone is way different than on a desktop or an iPad in cases of what you expect from the software to do. Because right now you're more used in using Excel on your desktop, because Excel is kind of a power tool for stacking numbers and creating tables and stuff. On the smartphone, you hardly use Excel because it's just friggling like smallish, like you can't even look at it quite that good. So our approach was actually and this is what we did not mention in the presentation when it came to my mind, that most of these insights we could directly implement in the mobile version. So the mobile version, as you can see it here on the right, with the principles showing on the desktop as well, but the mobile version was actually first in this process of contributing to it. And now, and in this process, we noticed that when we adapt this for the desktop, it's a bit of a different kind of thing. So if I would show you the very early designs of how the DeltaApp looked on the first desktop versions, it's way different from what we see now, because we did not have a feeling for the expectations you have as a user on a desktop, like right clicks, like menus, like context sensitive menus, like drop downs, like you are very more in a flow on the desktop than you are on your mobile device. So the actual application of all the rules and principles, we had this in the previous version for sure also. We also have another software which is called Delta Master, which is the tool Nick was talking about, what also was the company product and still is in many ways. But the mobile version was the actual breakthrough of really giving space to these principles, like making it interact. You might think, maybe we do, like because the mobile phone is very, very direct, not only in its visual confrontation, but also in its usage. Like you tap on something and something happens. Like you slide it, you scroll it, you swipe it. It's all connected in a very natural manner with your thinking and your visual impacts. So that's what I want to tell to that question. Another thing that is important for this Q&A maybe as well is like, where's this all going? We know that the visual sense is the strongest or one of the strongest we have as a human being, but it's not the only one, as you correctly stated. So where do we go? And we thought about this as well, and you can also inspect that or notice it in this screenshot. We are still working on it, so we don't have a very stable version, which on a live version now, but we made several tests with an own AI model we used to train with several data and data fields, and also have a department for this in our company as well. So you see here like a text box, and if we take one step further, we see what's behind it. And on the left, you see a graphical table, as we call it, like with the spark lines, with the red and blue coloring. It's a bit too much for now, but we want to know. Okay, that's an intense table. That's dense data coming together. And we typed, yes, show it to me, and please evaluate. And then our AI speaks out loud, the language model behind it, like, what do we find in this table? And that's where we want to go, because we see as our vision not only the visual sense appealed or focusing on the visual sense, but also on a text and word kind of sense, because the purest value of a number is its factor, and we want to try going this direction way further for now. Nick, maybe you wanna add something to this?
Yeah, I know that journey we discussed when preparing that talk about what is our opinion of AI and where do we see where it's going. Mm-hmm. And on the one hand, we are AI fanatics by heart. I learned the ropes at Forbes, which was in the 90s, the leading AI institute, and we got this prize for incorporating AI in our software. AI for us is a bit different from what is hyped now. You know, we are talking about linguistic modeling, language modeling, which is completely different from other stems of AI. And in business informatics, the view is a bit broader. In computer science, you strive to propel automation, the level of automation forward, because it's directly linked to any kind of progress. And for automation in our business intelligence field, we did different applications. It's automation of data modeling, automation of analysis. We have seen partly of that in the DeltaApp. Automation of visualization, perception. We have seen both in the DeltaApp. Automation of observation. Okay, and now we narrow that down a little bit to the use of textual analysis within our context. And we are totally fond of that idea. And Fabian just showed the one example that is most impressive. My concern is a bit, numbers must not be wrong, and nothing we tell about numbers should be wrong. And our clients would be very, very sensible of that. So we had a lot of progress integrating linguistic modeling into our RAM, but as the CEO, I want to have it bulletproof, because the big issue about AI, many people think they can now be dumber because the access to so much knowledge is so easy. That's not true. That's totally not true. You have to be much smarter now to differentiate, to be competent enough to decide, is it right what the machine is telling now? So this is a huge misunderstanding. And in business administration, we cannot afford to make mistakes here. So if we let the machine advise our clients, it must be a very smart machine. And so as a businessman, I have, for the time being, I have to be more reluctant. Mm-hmm. You know, in language, we are quite tolerant. If I understand you more or less right, we are both satisfied. But with numbers, we don't have that luxury. It's wrong or it's right, nothing in between.
Yeah, I thought that was interesting that you also said that in business, you don't need a third color that's yellow for some things that are maybe or decide later. I mean, something.
But and to this point, maybe in addition, like when it comes to the application of AI and how it may concern our product and our development and our vision, it might be that what can I really, what it can do very good is like finding stuff, or like going like facilitating process that you otherwise had to type in manually somewhere. So therefore we sure we are ahead of the processes, of the mechanisms. But as Nick rightly stated, it has to be right when it comes to numbers. It's not like when you speak different languages, you can express yourself in a different language, you can translate, but it's never the 100% conversion. Like, and that's what it makes hard for us. But for like applications regarding searching things, summarizing things, we can truly work with that.
Yeah, I think it sounds like you are moving ahead with caution, and that, you know, let's see what happens. It's also, as we know, moving super fast. And I think that it would be interesting to talk more about just the AI aspect actually of what you're building. Sure. However, I realize also we are a little short on time, and I wanted to say again that on LinkedIn, if you do have any questions, don't hesitate, and to also take in one from the chat, which is from Milton Kumar, who's a product design manager, sorry. And he's asking about a red text on a light background and the legibility. And he says, I feel there might be a contrast issue according to Google material design guidelines, and that he would love to hear your thoughts on this. So what do you say?
I'm not sure I got that right.
Should I repeat it?
Please say it again.
Red text on a light background, which is what you have in your app. So he's saying that there might be an issue when it comes to legibility.
Red text on a light background.
Yeah, just asking to hear your thoughts. Could also
Let me have a look.
it's just different of opinions.
Let me have a look. I still have the
Yeah, you can
Delta app
open the chat. You can
open.
Nick. Yeah, on the bottom line there's a chat, and then.
So let me maybe share again when I found the right thing here. Yeah, okay. So if I got the question right, this could be an example.
For example,
Yeah.
yeah.
So it is true that we had to deal with what intensities of blue and red can be combined with white labeling when talking about those examples. You know, that's a lighter red and it's a white text color. And here we have red on white. And it was an issue to think about the right span, the right bandwidth of intensities. And this is exactly what is fascinating me so much about our job. You can have the right idea, light blue is the better green, and blue and red does it, and intensities does it, but then it's a lot of detail work to find the right colors, to find how many steps there are in intensity. So all those new ideas felt a bit like riding on a razor, you know. It could be an idea of genius, but if we get it wrong, it's nothing. But this, I think, is what differentiates great ideas from ideas. So I would say it's well solved, that problem. I don't see any issues here in eligibility. But we had to think about it.
Yeah, from another point of view, maybe Nick, if you click on one number in the middle, like the 713K or something, or yeah, or like on a lighter KPI, so that it opens up. There you can see it maybe quite good. So we actually the question maybe is regarding contrast, and as we heard in the presentation of Nick and from the principles that derive from that, it's all about contrast and about seeing in the right way. So if we have a text written in red, as you can see here, the minus 48.1%, it's the biggest value. It has the darkest red, because also all colors can also be separated into brightness. And we chose this very wisely, like which blue and which red color has the highest and the least brightness, which is still recognizable in a matter of contrast on a white surface. So when you compare the 48.1%, you should guide your view onto that number. What's not so important is the minus 1.0%. And this one also, it's not even small. It also has a weaker contrast due to its light red intensity. So regarding the legibility, is for sure totally right, that comment, and totally right observation. It weakens the contrast and it weakens the legibility maybe, but it's supposed to. Like it's a made decision we did. Like we want to guide the eye and we want to guide it to the places that are important and not to the ones that are not so important right now, at least. So that's why we use these colors in that manner, also with lighter colors, because a lighter color means it's not supposed to be looked at that hard in the first place. It can, but it's not that urgent. So we want to separate the view, and that's for sure. I can totally understand that question, because it separates the general approach. Everything should be readable at one scope all at a time for all people the same. It's totally fine, but we need to make a clear decision on when we want to guide the view. We want to make rules for that, and also these rules might neglect something else for that, for the better or the benefit we wanted to achieve with this.
Yeah, thanks for elaborating on that. I think it makes sense that it's actually, when it comes to design, it's really about the details and like, what's the context? Is it that you're going to, perhaps Google's guidelines are also referring to reading text. Sure. This is not about reading text, for example. This is a different context. So very specific to your app. Though it's already 6, I would like to take the last question from the audience because it's an interesting one, and then we will wrap up. And it's coming back to the AI. So what were the boundaries you set for training the underlying algorithm? What was key for getting correct responses, and what can go wrong here? And you could stop sharing again. Ah, perfect. Yeah.
Yeah, there's a lot of things that can go wrong, and also they did go wrong. Like we had big problems training the AI. In the first place, comes to my mind regarding the vocabulary. So for when you work with people in business and people make business decision, every company has its very own structure of dealing with things, with departments, with logic, with processes, with everything. So each company mostly also have different vocabulary for several things. So one very hard part one big challenge is to somehow gather information about, okay, this vocabulary now is set for this and it has a tolerance which is that big. And then we do not talk about a difference between this and this, but also in other contexts. So it's pretty hard to differentiate because the vocabulary is very complex in that manner, and we had to struggle with this. But as we said, we're still moving on with this target, and it's still a vision to follow up. And right now, for sure, we have to admit it's not stable enough to pull through, even especially not this year. But we will keep working on this for sure.
Do you want to add anything, Nicolas?
I think Fabian, you got it right. We could add a lot of more stuff we have to take into account, and that adds to exactly what I said. Yeah. The robustness we really need to, we are doing standard software, and the most astonishing thing with DeltaApp was, imagine a business intelligence project where every report can be designed specifically to whatever the client thinks is right. It's eating up all the time. And the result will anything but perceptual design. So the DeltaApp completely killed that problem, because we put in the structure of the data, we put in the KPI, and what comes out as reports, as dashboard, is done automatically. And funny enough, not one client ever discussed the design of the DeltaApp. And that, before, the report design discussion ate up a lot of the budget, and it created reports that used our options not in the right way. It was a constant source of sorrow. If you see your own product used by customers who do not integrate all the things you invented before, you're totally disappointed. And this cannot be the case with the DeltaApp. And that was a huge step of automation. And to be frank, it took us 20 years. So I'm not the least bit, how do I say, alarmed if it will take another 10 years, say, until we say, now it's the time for linguistic modeling and financial controlling, and nobody will ever find something that is bad about it, No problem. We have been around for 30 years, and we plan for the next 30 years. So there's absolutely no need to bring these things further than it is feasible and reasonable.
That's nice to hear also, because it feels like there's such a rush right now, and everyone like mindset of having to do things first and fast. Yeah. So it's good with long-term perspective, and we really look forward to seeing what happens with the app, and also to follow your research, do a part 2 perhaps Not
you.
in 20 years, a little bit earlier, maybe.
The book will come out next year.
Let's see what happens.
Yeah, fine. No, it was great fun to be with you. Thank you very much for the invitation and for the audience. And yeah, we come back soon if you want.
Yeah, super. Thanks everyone for joining us. Thanks Fabian and Nicolas. Stay tuned here on LinkedIn and social media to find out more about our next event. Next Wednesday, we are streaming again our jury digest, which is a conversation between 4 jury members from the previous UX awards. And it's full of insightful tips and a great conversation, well worth watching and timely. So don't miss that one. And yeah, auf Wiedersehen, auf Wiederhören.
Auf Wiedersehen. Dankeschön.
Alles Gute, vielen Dank.
Ciao.
Bye. Take care.
Bye-bye.